that should be done. Perfect. So thank you very much for coming in this session on citation impact. And so today, what are we going to see? So today we're going to see mostly what is citation impact, the definition of citation impact, and how it is measured. And then we're going briefly to see which tools we have to capture citation and which action actually we can take to increase our citations, okay? Just a small disclaimer before I start. So I just want to make clear that basically all the information that I present in this presentation are not exhaustive. So there are other tools available and there are other metrics available as well, okay? I'm just going to present the most important one, the most popular one. Okay, so before I start, I want to show you 3 points so that I would like you to remember from this presentation. Okay, so point 1 is that citations are not a measure of quality and must always be used in the right context. Point 2 is that citation metrics vary across databases. And point 3 is that research quality and open research practices are the best way to enhance citation. Okay, now I'm going to talk about these things and see what they are about. So first of all, so what's citation impact? So citation impact is defined as a measure of the frequency with which an academic paper is cited in other publications. And so from this definition alone, you can understand that citations are a quantitative measure, okay, not qualitative. Okay, could you please, I think someone has the microphone on. If you can please switch it off. Thank you. And so why citations are important, actually? Because why do people cite? People cite someone else's work to give credit, okay? So there is this assumption that the more your work is used by other researchers, the more credit you get, right? And for this reason, citations are considered an indicator of the intellectual contribution of a researcher to his field. And so because of this assumption, so everything is based on this assumption, citation impact is often used to assess research performance, okay, not alone, usually with other indicators. And so they use it to assess research performance for individuals, but also for organizations, okay? But of course, so you might be thinking, do all citations actually give positive credit to someone? So the fact is that we don't know. So we cannot know from the citation only. And it happens a lot, actually, that people cite to disclaim a popular work or to disprove a theory, or, for example, you want to claim that a methodology is wrong. So not all citations are good, okay? But we cannot know that only by looking at the number of citations and the citation impact, okay? So citations do not provide any type of context, okay? Another big problem with citation is there are many cases of inaccurate attributions. So, for example, let's say you're reading a review and you find something like a study that is interesting, but then in your work, instead of citing the study, you cite the review instead. Okay, so this is a wrong accreditation. And then there are many cases in which citations are just wrong because of typos, or maybe you cite something in the text and then in the references you write down the wrong article. So there are loads of mistakes, actually. There are lots of studies that are looking into it. And also, you have also to be mindful that citation usually reflect the impact, but in the academic circles, okay? They don't usually reflect the impact of a research outside. So the only thing you can do to use citation to see if you have an impact outside of academia is actually see if you have been cited, for example, in policies or things like that. More importantly, so citations have particular features that must be considered when we evaluate a piece of work, okay? So first of all, there are differences due to gender. So there are many studies, in particular lately, that have found that women are cited less than men, and it's not known why. But if you compare like the same type of study, same journal, even if women and men are both first author, you will see that women are less cited. And we still don't understand why this is happening. And also, citation, of course, are document type sensitive. which means that according to the document you are publishing, you might reach a different audience, and for example, reviews usually reach a broader audiences, so they receive more citation on average than like original research. And also, of course, you have to consider when your publication was published, so the publication date. So how old is your article? And of course, this seems kind of obvious, but citations tend to accumulate over time. And so, of course, the rate at which this happens depends on the field, but it is usually, we think, an average 2-3 years are needed to have a meaningful number of citations to actually judge an article. And then, of course, there are also, actually, this is a bit of a curiosity, because there are some papers that they're called Sleepy Beauty. So, and there's this kind of paper that do not receive any kind of citation once they're published, okay? So they don't receive much credit. But then suddenly after 50, 60, or 100 years, for example, they have a boom in citation, okay? And this happens, for example, in physics and chemistry, where we have theory that are much more advanced than practice. So when they are proved many years later, they have a huge amount of citation, but it's like 60 years later, stuff like that. Okay, and another important feature is that citations are field sensitive. So the number of citations that you can have varies a lot according to the field you're publishing in. Okay, so this is basically chart that show you how scientific subject usually gets a much higher number of citations than arts and humanities. And in the table here, you have the different characteristics, so different things that we expect from citation so if we compare science from humanities, okay? And so one thing is important that, like in science, usually we use citation as constructive, so something constructive, but in humanities, they are usually used as a rebuttal. And it's also important to see that in humanities, lots of papers are published in original language, or language that is not English. And this, of course, contributes to much lower numbers in citation because you can reach small audiences. Okay, so my main point is when evaluating citation impact, you have always to consider the wider context. Okay, so how can we measure citation? So there are different ways, different indexes available. And so we have the not normalized indexes, for example, the citation count, the mean citation count, or the H index. And these have big limits in a way, like they don't provide any context. So they don't consider the field, the type, or the document type differences. And then we have the normalized indexes that instead consider these kind of differences. So they can be used for comparison. Okay, so from the normalized indexes, I'm going to talk in particular about the H index, because it is an index that has been used to compare researchers, but in the wrong way. So the H index is actually a metric that was introduced by Hirsch in 2005. And basically, what does it mean? It means that if you have an H index of 5, you have 5 publications that have received at least 5 citations. Okay, so that's it. That's everything that the index actually gives you. So you will understand that this index basically has loads of limitations, okay? So first of all, it doesn't give you any kind of information about your citation pattern. So what happens if you have a highly cited paper? So this is not taken into account. You might still have an H index of 1. And then, of course, because citation increase during the years, so you cannot have less citation the more year passes, okay? They can only increase. So this index favors a lot like senior academics or someone who has a longer career, okay? So it's really not good to be used to compare researchers. And here you have an example. So if you have, for example, 3 researchers, so you have one with an H index of 4, one with 2, and one with 3. So which one do you think it would be best? So you don't know actually, because you might say, okay, maybe the one with the H index of 4, because it's the highest. But then if you look at the publication, this is what you might see. So you might see that the first researcher has actually, okay, a higher H index, but then it has lots of publication with no citation at all. The researcher B, has a couple of papers with very high citation, and the researcher C has fewer papers, but all of them have been cited. So you can't really compare using the H index. You lose all the other information that are useful. Okay. So instead, for the normalized indexes, so like I said before, this one they take into account the year, the document type differences, and how they do that. So basically, it's quite simple. So you just take the article citation count, and then you divide this by the expected citation. So the expected citation is the average number of citations that are received by the articles that are in the same field, published in the same field, in the same year, and the same document type, or the same journal, the same years, and the same document type. So where do you find the expected citation? So these are usually given by analytical tool. So here you have an example of Insight, which uses data from Web of Science. So we'll talk about this a bit later. So here you see these tools, they give you lots of metrics of articles and other metadata. So for example, here you have the times that an article has been cited, and here you have the indexes and the expected citation. Okay, so let's say you have the journal expected citation is 38 per 22. So this means that all the other paper, the same type of yours, that has been published in the same journal in the same years, receive on average 38.22 citation. So if you want to calculate your index, you just divide the times you have been cited by the expected one, okay? And you come out with the index that is 1.62, which means that your article received 1.62, so did 1.62 times better than the average, okay? And the same is for the category expected citation index. So basically you do the same, you have your category expected citation. So these are the citations you would expect for the same type of article published in the same field in the same year. Okay, so you do the same, you take your citation, you divide it by the expected index, the expected citation, and you get your category normalized citation impact, which is 2.34. So that means that your article did twice better than the average. Okay. So this index is usually used to benchmark institution. So usually when you compare institution, you use this kind of index here. And how they do, basically they just take all the average scores of all papers that are affiliated with an institution, and they compare averages between institutions. So you will understand that because you use averages, so the big limitation of this index is that they are very affected by extremes. So if you have a set of very highly cited paper or a set of non-cited paper, this will affect a lot the score. So are not indicated to evaluate small sets of publications, okay? So they work better for larger sets. So as the last index, I want you to show you the percentile. So this is my favorite index, if I have to be honest. And because it gives you a context more than the other indexes. So how does it work? Basically, you have first to define a set of reference articles. So let's say you take all the articles, a set of papers that have been published all in the same field, in the same year, and the same document type. So you take them all. Then you rank them. So you create a list from the for the one that have been cited the most to the one that has been cited the least. And finally, once you have your list, like here in the table, you divide this list into percentiles. Okay. So in this example, you have 1,000 papers. We say we have 1,000 papers. And then you have to see which one is the top 1%. So the 1% of 1,000 is 10. So the first 10 papers are in the top 1%. Then if you want to see the top 10%, so the 10% of 1,000 is 100. So the first 100 paper of your list will be in the top 10. So what does this mean? Basically, it means that if you have a paper in this 10 here, so in the top 1%, it means that 99% of all the other papers that have been published the same year, the same field, have received fewer citations than you, okay, than your paper. And if you are in the top 10, it means that 90% of all the other publications have received fewer citations than you. Okay, so you can see that in this case, you have a context. So you know exactly where you stand. So yes, the good thing is you have a context, and as well, this index is not influenced by the extremes because you don't use averages. But of course, it has some limitations because you use ranks. So for example, what happened with papers that have an equal amount of citation? So in this case, usually, or you give both a half rank, so they both are number like 3.5, 3.5, and then there's no 4. Or you use the same rank, so you have 2 3s and there's no 4. Okay, so because the amount of paper in one rank should be the same. And what happens as well if you have an article in multiple subject categories? So in this case, usually, so for example, let's say you publish in biology, but your paper can be categorized in biology and geology because it's something interdisciplinary. So your paper is going to be scored in both categories. And then usually databases assign the highest score. Okay, so one thing that is important to mention is that citation metrics in general have been largely misused in the academic context. And it's because, so the main problem is that they've been used a lot as a measure of quality, okay? But so I hope that really it is clear that citations are not a measure of quality, but they are quantitative measures, okay? So then they should never be used to judge the quality of a particular paper, in particular, if you don't consider all the wider context, okay? And so, but because of this, because they were used as a measure of quality and they've been used a lot for promotion, recruitment, in funding decision, they have supported lots of bad behavior, let's say, among researchers. So one of those is the goal displacement. So when, for example, author started choosing a topic not because it's important or it's of interest, but because it brings more citations, okay? And then there have been lots of cases of extreme self-citation in which a researcher just cite their own papers. And also there have been what is known as citation lobbies, in which, you know, there are a group of researchers that were contacting each other and citing each other's paper, okay, to increase their numbers. And then, of course, so I will talk a little about the journal impact factor. So this has been one of the most misused metrics at the moment. So I haven't mentioned it at all at the moment because basically it's not, so the first thing to know is not an article metric, is not an author metric, but it's a journal metric, okay? So it's a journal metric that was created with the intention to advise librarians regarding like which journals actually to add to the library collection, okay? So it's not created to give an information about the articles, okay, but only about the journal. So of course it is calculated with a citation, but so it gives you an indication of the visibility of a journal, okay? So how is measured? Basically it is measured by calculating the ratio of all the citation received by the items in a journal in a specific year, divided by the amount of citable items. So the citation received by the citable items in the 2 years before, the 2 previous years. Okay, so it doesn't have to do with the quality of a single paper. And so you can see also from how it's calculated that this index created loads of problems, because in the numerator you have the citation of all published items, which means that this includes editorial materials, okay? But at the denominator you have the citable items only, which doesn't include editorial material. So you would understand that this impact is very easy to manipulate, because it was enough, for example, a journal, if it wants to increase the score, can just decide to publish more editorial material, okay? So you publish more editorial material, your numerator is higher, so you get a higher score. And this has been done So this was a kind of malpractice that this index basically created. Okay. And then, of course, it pushed also for other editorial type of malpractice, because editors started to suggest citation of particular journals during peer review. And there's been also many studies that found out about citation cartels, where there were mutual agreements between journals to cite each other. And all of this just to increase this index. So in response to this, because this has created lots of problems, and in particular because the journal impact factor, for some weird reason, has become like a synonymous of research quality, right? So someone was thinking, if I publish in a journal with a better impact factor, my article is considered better quality, but it's not the case. But in response to this kind of malpractice, there have been several initiatives, and one of the most important is the DORA. So DORA is the San Francisco Declaration of Research Assessment, and basically it establishes some guidelines on how to use metric responsibly. So it has many recommendations, and here I'm showing you just the general one. And basically, if you can see, it's really spot on that. So it says that we cannot use journal-based metric, such as impact factor, as a surrogate measure of quality for individual research article, or to assess individual scientists for hiring, promotion, and funding decision. Okay, so it was a big problem. And now, and after DORA, there have been many other calls that wants to reform research assessment, and like, for example, the metric tile from UKRI or the Leiden Manifesto. Okay, so, and with this, we are arrived at the first point. Okay, so please keep in mind, citation are not a measure of quality, and really, if you have to look at your citation impact, always consider the context. Okay, so which tools do we have to capture citation? So there are many tools available and many databases. So here I report only the most popular one. And the one used most widely in the university is Scopus and Web of Science. So the University of Aberdeen actually subscribed to Web of Science. And we use Insight, that is the one I showed you before, which is an analytical tool, basically that provide all the metrics. So we use this analytical tool for all our matrix analysis. Okay. So an important thing about databases is that each of these providers provide citation numbers, but only for the publication that it has in their own databases. So the citation counts in the end differs from different databases. Okay, now we'll see why. So as you can see in the table, the coverage of the databases is different of quite a lot. So here I have Web of Science, Scopus, and I put a big question mark in Google Scholar, because although it's known that covers the most, so it has the biggest coverage, so we have no idea which kind of source it takes from. So there's no lot of transparency regarding Google Scholar. Okay, but as you can see, the sources are very different. So the metrics that this database provided are different. So the main difference is that Web of Science and Scopus mostly rely on a set of source selection criteria. So the selection criteria is applied by editors, and these editors decide which sources to include in the database. Okay, instead Google Scholar does not have this, so it goes a bit more, let's say, a more inclusive approach, but it's an automated approach. Okay. And so what happened? Basically, this selective approach of Web of Science and Scopus produces this curated collection of documents, but it's much more sensible to biases criteria. Okay. For example, there is a lot of evidence that Web of Science and Scopus have limited coverage of social sciences and humanities. And that's why usually they don't cover well any kind of literature that is in a different language than English. Okay. Instead, Google Scholar is much more inclusive, but it's unsupervised. So it does have lots of errors. There are lots of mistakes. in particular databases, the metadata mistakes. You can find lots of duplicates in your accounts. So yeah, it's less transparent because we don't know which kind of sources actually are indexed in Google. Okay, so having this in mind, so one of the questions we have often is like, why do I have like such a different citation count, for example, in Google? So why my citation count is so high in Google and so low in Scopus? Well, this is exactly for the reason I mentioned before. So because they just take data from different sources. So if you look here, this is the profile of the same person. So you have Google Scholar, you have more than 4,000 citation, and then Scopus, they drop to 2,000. And in Web of Science, they are just below the 2,000. Okay, so the amount of citation is different according to the databases. And this is why it's very important. So if you want to present your research matrix, your citation, it's always very important to specify where the numbers are coming from. Okay. And another thing that I want to show you here, so connecting to what I was saying before. So if you look, for example, the number of citations, okay, you would say, okay, this researcher has a quite good number of citations, they're quite high. However, you don't know in which field it is, right? So if it's in the medical field, this number of citation is quite common. So Web of Science gives you here the citation percentile of the publication. So as you can see, so the green dot here gives you the average percentile of the citation. So in this case, it's on the 80. So this what I will show is the reverse percentile. So it means that if it's on the 80, it means that 80% of other publications have lower citation than you, okay, than this researcher. So it's in the top 20 percentile. So from here, as I was saying before, using the percentile, you get a much better context, okay? It doesn't matter really much on the field. Okay, and so with this, we cover kind of point 2. So citation metrics really vary across databases. So keep this in mind and always specify where your data are coming from. Okay, this is just to give a bit more context. So citation, as I say, they're not used only to evaluate individuals, but they also use, for example, to assess universities. And so in this case, here I'm presenting the league table. So for whom is not familiar with the league table, these are basically university rankings that are published every year. And they use different metrics basically to define the strengths and weaknesses of institutions. So why they're considered important? So they are considered very important because they have a big impact on students, but also academics recruitment. Okay, so for example, there are some countries which fund students only if they are accepted in the top 100 or top 200 university. Okay, so citations are here. So are one of the metrics used actually to evaluate research in the league tables. Okay. So of course they have different weight according to the league table, but citation is the purple. Yeah, so you can see, for example, in the academic ranking of World University and in the US News Global University ranking. So they count a lot on the final score. Okay, we have 60% here and 75% here. So yeah, so they have huge impact on how the university is evaluated. Okay, so and where do this league table take the data from? They take the data from Scopus and Web of Science, of course. Okay, so for this reason, it's very important. So not only for you, but also for your institution, that your citation metrics are actually correctly measured in these databases, right? So how can you increase your coverage? So how can you improve the accuracy of your metrics on these databases? So there are two different ways. So first of all, you can fix your researcher profiles. Okay. So basically, how does it work? So when you have a publication that is on one of the index journal of Scopus or Web of Science, let's say, so this database creates automatically a profile for you, okay? So, and then what happened? Basically, it happened that if you are not consistent with your name, so for example, let's say in one publication you are John Junior Smith, and in another you are John Smith, and then it might happen that in between publication you also change your affiliation. So what happened is like the database creates two different profiles for you, okay? They don't recognize you as the same person. So this happens very often, and what happens basically that your citation count is split in between two different accounts, and so it would be much lower. So it's something very easy that you can do. You can go on your research profiles on Web of Science and Scopus. You can check if you have more than one profile, and then you can merge them. It's very easy. So you can follow here these two links for instructions. And yeah, and you can check also if your publications are correct. And as a pro tip, you can also link your profiles to your ORCID. So the ORCID is a researcher unique digital identifier. So if you don't have one, you will have to get one because anymore is requested for everything. So it's also mandated by most funders, and also if you publish anymore, many publishers also require the ORCID, okay, as one of the data that you have to provide. So if you don't have one, you can follow the link here, and it's very easy. You can register, it's free. So I would really suggest to do it. So once you have it, always with a couple of clicks, you can link your profiles all together with your ORCID. And then once you have a new publication, everything gets updated automatically, okay? So you don't have to spend time to do any kind of admin anymore. So another thing otherwise you can do is, for example, let's say if you have a publication on a journal, or if you want to publish in a journal that you know that it's not indexed in these databases, but you would like to have the citation of this particular publication counted, you can actually encourage the publisher to submit the journal, or the book, or the conference proceeding to, for example, the Web of Science. So here you have some link on how to do that. Okay. Okay, so in my very last slide, I have a couple of some tips how to increase citation. So the first one and most important one is, of course, there's no better way to improve citation than writing a good piece of literature, good research, quality research, okay, and the original research. And when I say this, I don't mean like that you have to, so research quality doesn't mean that you have to discover the moon every time or find something amazing. It just really means as well, be rigorous, your methodology, make sure that everything is reproducible and things like that, okay? And of course, another thing you can do that is very important is to follow open research practices. Okay. And if you do that, of course, it would be good for your citation, but it would be good also to improve research culture. Okay. So how can you do that? So first of all, you can use preprint servers. So preprint servers basically are these archives where you can update your manuscript before it has been peer reviewed. Okay. And this is a very good way to increase your visibility because your paper is out there. You increase transparency because everybody can see the different stages of your research. And so it's considered a good thing. And there are many available. So here you have some examples. But if you have some doubts on which one to choose or how to go with it, you can just drop us an email, okay? And we can help you with that. Another thing you can do, of course, is make your manuscripts open access where it's possible. And so there are different ways you can do so. You can do so by, for example, depositing your accepted manuscript in the university repository or other repositories as well. And this is free. And okay, so if you don't know how to do it as well, in this case, you can drop us an email and we can help you with that. And otherwise, you can also decide to publish, for example, gold open access. In this case, it's not always, but in most cases, there are fees involved. But you can publish gold open access by using one of our read and publish deals. Okay, these are available to all corresponding affiliated authors. Okay, so I'm not gonna give you too many details, but here we're gonna have a session at the end of February on how to publish open access. So please go to this session to have more information. And then, of course, also make your data, software, and code available where possible. Also, these there are evidence that say that having data available increase citation. So, yeah, paper with supporting data are associated with an average 25% of increase in citation. So it's quite a big number. And also for this, we are many repository where you can share your data, like Figshare, Dryad, or SlideShare. But also in this case, we're going to have a session dedicated on how to make your data open on the 21st of February. So please attend this as well, okay? And then, of course, collaborations. So if you find co-authors, in particular international co-authors, who collaborate with peers, so collaboration usually it's a very good way to increase your audiences and increase your visibility. And the best thing as well you can do is just to get out there, be proactive in promoting your research, share your research on social media, go to conferences, take advantage of, for example, department talks or department conferences, go to public engagement events. So everything that you can do to make yourself and your research stand out, okay? And this will have the third point. So that yes, research quality and open research practices are actually what can increase your citation, okay? And with this, I'm done. So I leave you with this slide with our next session. And now we stop the recording. So if you have any question,